Alright, and now they're saying in question 3, BCD is a right-angled triangle with CB produced to A and CD produced to E and F. And BD is parallel to AE, and cosine AEF is negative 5 over 13. Okay, that's interesting to note, AEF. Just gonna kind of note it down here. Kind of color code it a bit. Okay, express as a fraction the value of cosine BDC. Okay, so we're trying to find this one. So if I know that cosine AEF, right, is negative 5 over 13, one thing I definitely know is that cosine of AEC is positive 5 over 13. And once again, we go back to this, and you can see in the previous video, right, that cosine of theta equals to negative cosine of 180 minus theta. Yep. And so we can easily see that if cosine of AEF is negative 5 over 13, then cosine of the angle, 180 minus that angle, which is simply AEC, would be the negative of this, so it's negative of negative 5 over 13, so that's positive 5 over 13. Okay, so we found that. What about BDC? The thing is, if they tell me that these two are parallel, and they're along this line, so these two are therefore equal because of corresponding angles. So AEC is actually equals to BDC because of corresponding angles. And so immediately, if the angle is the same, I can also say cosine BDC is therefore also 5 over 13. Yep. Okay, that's part A. Let's do part B. Tangent of DBC. DBC. So I'm trying to find this one. DBC. Tangent of that. Okay. I try to see. Did it give me any lengths at all? No. No length. So I only have angles to base off. The good news is that I already know the cosine of BDC. So if the cosine of BDC is 5 over 13, that means the actual angle itself is simply the inverse, right? Cosine inverse of 5 over 13. So that's the angle, right? And so to find the red angle now, DBC, right? What I can do is I can say that, okay, DBC angle is simply 180 degrees, subtract away 90 degrees, and I subtract away this angle, which is actually cosine inverse 5 over 13. Once again, you can key in cosine inverse 5 over 13 and then have a whole string of decimals, but I just like to keep it this way so that I don't accidentally round it up or down. In fact, we don't just need DBC, we need tangent DBC. So I'm not even going to simplify too much over here. I'm just going to leave it as 180 minus 90 is 90. And I'm going to leave it as this, negative minus cosine inverse 5 over 13. And then I'm going to say tangent of this entire thing is therefore tangent of this. And if I key all of this into my calculator, right? So I can key this in first. 90 minus this, and then I tangent the result. You can do that as well. Yeah, so you don't round up or down at all. You will see that you get a nice fraction, 5 over 12. Okay. Now let's do part C, sine of DBA. So let's go to DBA, that's sine of this angle. Alright. So the way I can solve it now is I know that tangent DBC is 5 over 12. Right, tangent of this is 5 over 12. So this angle is actually tangent inverse of 5 over 12, the angle itself. So sine DBA is simply, if I were to do it maybe here, part C, I can say that DBA is simply 180 degrees minus tangent inverse 5/12. Okay, and I'm going to leave it as that like just now, and I'm going to say sine of dBA is therefore simply sine of, open a big bracket, 180 minus, like this. Once again, key this into a calculator first. Remember the inverse, and then you sine of that. Yep, and then you will get 5/13 as well. There you go.